Alright, so another example from your book. I believe it's example 2 from this section 9.3. They ask us to rewrite the sine of 3x in terms of sines and cosines of only x. Okay, so at the expense of whatever powers we might have to bring into it. Alright, well, sine of 3x is undoubtedly sine of x plus 2x, right? And we have a way to break down the sine of something plus something else. Remember the addition identity, sine of a plus b? That's just sine of a, in this case x, times the cosine of b, in this case 2x, plus cosine of a, sine of b. Alright? Well, that's a step in the right direction. We've gone from 3x as an argument to sometimes x, sometimes 2x. So what we have to do now is we have to break down these two, the ones that still have a 2x in them. This one's pretty easy. The sine of 2x is what? What's the identity for that? Right, that's just 2 sine x cosine x. Okay? And this, well, there's three choices for this. Which one's going to be easiest? It doesn't really matter. I think personally I would probably choose the one that only involves sine. Since it's already multiplied by something involving sine, it'll just be simpler. So what's that? I think it's 1 minus 2 sine squared x, right? So all we're going to do is rewrite all this mess, replacing these underlined things for what's beneath them. Alright, so we'll see how that looks in just a minute. Alright, so I've done as I said. I've replaced these two underlined parts with what I've written below them, and that works out like this. Now looking at the problem's directions again, I see that I overlooked something. We're supposed to eventually put everything in terms of only sines. Okay, so distributing this multiplication and working this out, I end up here. And so I'm not done because I still have a cosine. So how can I turn this cos squared x into a sine? Something to do with sine of x. Right, we've got the Pythagorean identity. This we can write as just 1 minus sine squared x. So doing that, we're going to end up with a nightmare. Over here is just sine x minus 2 sine cubed x plus 2 sine x times 1 minus sine squared x. So I think it will simplify a little bit in the end. 2 sine cubed x plus, if I distribute this, I'm going to get 2 sine x minus 2 sine cubed x. So I have this and this, which add together to give me 3 sine x. And then I have this and this, which give me minus 4 sine cubed x. Okay, so what we've really done here is we've changed this so that the argument is now only x. Everywhere you look, the argument of the sine function is x, x. And the price we've paid for that is we've made two terms out of it, and one of them has a cubed in it, right? So the complexity we had in the original is sort of still here, but it's in a different form. And so you have to really read the directions carefully in this kind of problem to figure out what exactly is it they want. In this case, they said change this so that the argument of all the sines is just x, not 3x, not 2x, but just x, and eliminate any cosines, put them in terms of sines. And these tricks that we've used are very typical. If you have cosines and you need to change them to sines, this is always an option. If you need to go from a multiple angle, like this, into a single angle, you can use the addition identities. You can use the double angle identities. Alright, we'll move on to some new stuff in the next section.